Welcome. My name is Eduard Hohenhöfner. I work as a software engineer at Tabular, and I get to work on a bunch of stuff around the Iceberg project. Namely, also I was involved in a bunch in different aspects around Iceberg views, and therefore, yeah, I'd like to welcome you to my talk about Iceberg views and how they work under the hood. Um, what can you expect today? So first of all, we're gonna take a quick look. How does Apache Iceberg work? Just a short overview, and we're gonna switch over to discuss real quick what are views in different engines. How do those look like? And the next section will cover Iceberg views and how we got where we are, and we'll conclude the talk with ongoing and potential future work around views. So let's take a look at Apache Iceberg. I mean, the main reason why we're all here is we want to know everything about Iceberg and how cool it is. So Iceberg is essentially an open table format. Um, I think the simplest form of how to understand what it actually means is um, Iceberg essentially tracks the data files that belong to a certain table, and that helps in answering the question. A query engine comes in and asks, like, what data is in this table, and Iceberg will answer that because it tracks data files. The big advantage of Iceberg is that it is engine agnostic, meaning that you can come in from Spark, create a table, and read it from Trino, and also write to it from Trino. So it's like simply because all of those engines talk the Iceberg format and talk the same language, essentially. The main features of Iceberg are you can do time travel. So you can actually go back in time and look at your data at a certain point in time. Um, yeah, Iceberg, essentially the at the core of Iceberg is Iceberg doesn't want to surprise you with side effects. Think about safe scheme. You can do safe schema evolution while running other concurrent updates and inserts and read data in a safe manner. So it is safe to do you know dropping a column and adding a column and things like that. Iceberg supports partition evolution, so you can just evolve your partitions without having to rewrite all of your data. Um, a very recently added feature is branching and tagging support, and Iceberg provides transactional guarantees. And I think also one of the like a core feature is that it works with different cloud storage providers. So what Iceberg essentially is, it's a table format specification. It defines how data files are tracked and how the metadata underneath looks like. It is essentially an API. It's essentially a set of APIs and libraries that engines use to interact with the tables that follow this specification. That means also, Iceberg is not a storage engine. It's not an execution engine, and it's not a service. Looking at Iceberg from this perspective, right? We have it here in kind of like the middle layer. At the bottom, we have object storage. So, and the idea is, you have one single copy of your data living at the object storage, and Iceberg enables you to bring you bring your compute to your storage simply because those engines all talk the same language. Like I mentioned before, it is fairly easy to read and write to a table from Trino, but also see the same updates in Spark, for example. Um, just a short overview of how Iceberg tracks data and metadata files, just for us to have a quick understanding of how things work internally. So let's assume we are running a query, and at the core, we have like the very first point of contact for an engine is the Iceberg catalog. The main purpose of the Iceberg catalog is to tell the engine, I'm tracking those and those tables, and they consist of those and those files. and the catalog must support an atomic swap. That's like one of the core principles behind this. And so essentially what will happen if we execute the query, the engine will go look at the catalog. We'll see that the current, the current metadata pointer points to this metadata file. We're looking at the latest snapshots. So those are snapshots. So at one point in time, there was only this metadata file consisting of one single snapshot. Then there was an update, and now we have a metadata file with two different snapshots, and the S1 being the latest one. So we will go to this metadata file. We will see the latest snapshot is this. And that snapshot is essentially tracking manifest lists, and a manifest list is keeping track of multiple manifest files. And those are then in turn keeping track of respective data files. And at each layer, so you see we have multiple files, and at each layer, Iceberg is keeping track of additional statistics. So each layer has some additional statistics that helps in making efficient, to do efficient pruning, so that we, in order to answer a query, so that we know at the metadata level already that we can skip this and this manifest file, and we only need to look at maybe one or two data files here. So that makes Iceberg very efficient when doing query planning. Let's take a quick look on what views actually are. Views are essentially virtual tables containing real rows and columns of an actual table. When you create a view, there's a underlying query definition that is executed whenever the view is created. You can think of it in terms of it's essentially a logical view of data. If you have very complex queries and you want to reuse those complex queries that provide a subset view of your data, this is where views would come into play. It is important to note that views by themselves, they do not contain any data. So, and the upside to this is whenever that view is being queried, you will always get the latest, whatever latest data is in that table. But that also implies that the performance of that view essentially depends on the underlying SQL. Now let's take a look at a view example in Spark. So we do a create or replace view for, so we want to figure out, what are my most experienced employees. What we do here is we give the view some custom schema. We have an ID. That ID field has a comment and a name. The view gets a comment, and this is the underlying query. We're selecting ID and name from that table where the working years is greater than 5. And that means whenever we query that view, we get this subset of data that is defined in this query. Here's another example of a global temporary view. I mean, details don't matter that much here, simply because we just want to see, how views look in an engine. Same goes for Trino. So here are a few examples of how to create a view in Trino. It's fairly similar to Spark. There are still some tiny differences in the syntax and some other things, but essentially it's doing similar things. Like you create a view, you give it a name, there's an underlying query, and whenever that view is being queried, that SQL will be executed. Now switching gears to Iceberg views. So as we saw, views are supported by different engines. If we look at Spark, Trino, Flink, views are supported. The problem is rather that the view metadata itself is specific to the engine. So it's not really possible to create a view in Trino and then read from that view Yeah, because my mic went off. Yeah, so the problem is that views are, yeah, exactly. You cannot read from a view in one engine that was created by a different engine, even if those engines share the same metastore or storage. And so the overall goals that we want to achieve is we want to have cross-compatible views that work across engines. And that means there will be a common metadata format for views, similar to how Iceberg supports a common table format for tables. What it actually means is, so getting views into Iceberg was a big community effort. It essentially consisted of those 4 bigger steps. So we started with writing at the view spec and how views will look like at the metadata layer. How we model things. Once the view spec was done, the community was focusing on defining different view APIs and their implementations. And once that was done, the next step was essentially integrate views into catalogs. Like, there are different catalogs that already support views. And so once you have support in catalogs, the next step is adding views to engines. As I mentioned before, views are essentially modeled after Iceberg tables. That means view metadata itself, similar to how we saw it with Iceberg tables in a few slides before, is the view metadata is tracked in metadata files, and every change to a view essentially creates a new metadata file. And so every metadata file is fully self-sufficient and contains all of the information needed to describe a view. Iceberg views have been available since the 1.5 release, which was released about 2 months ago. So the current catalogs that support views as part of that release is the REST catalog, JDBC catalog, NASI catalog, and there are also other catalogs like Hive. It's currently we're working on those right now, so it's will be shipped soon, but it hasn't been released yet. And in terms of engine support, Spark is essentially our reference implementation. We have support for Spark 3.4 and 3.5. Trino support is, I think, very close. It's currently under review, and essentially the Trino support had to wait for the 1.5 release in order to continue, and then in order to add the view support to Trino itself. Having a quick look at the view APIs. It's fairly simple. We have a bunch of APIs. When an engine, loads a view, the view itself carries a current version. It tracks, what is my current schema. There's a list of versions, a list of schemas. There's a history, some additional properties, and some other fields like UUID, name, and so on. The view version tracks the version ID, the timestamp when that view version was created, a summary field, the current schema ID that the view points to, some details about what is the default catalog and namespace to be used when the underlying SQL actually does not have any information about catalog and namespace. Like if it's not a full identifier, so we track those here. And then there's also a field called representation. So it's essentially there's a list of representations of how this view is represented. Right now, there's only a single type available. It's the SQL type. And the SQL view representation is, we have a SQL, which is the plain SQL from that engine, and dialect. And the dialect essentially, if the view is being created from Spark, then the dialect will be set to Spark. If the view is created from Trino, that dialect is created. That dialect is set to Trino. And there are certain edge cases that can happen. That, for example, the underlying SQL isn't portable from engine 1 to engine 2, and we're very aware of that. So in upcoming, like in the future work we'll see later, that we're planning to improve and add new ways of how to represent views. And here we have essentially view history, where we keep a track of like how did the view evolve. So we track the version ID, and it's perfectly fine in the history to evolve from version ID 1 to 2 to 3 to 1, which would then indicate that there was a rollback to a certain version. And the timestamp here is not necessarily the same as this one, because that is the timestamp when that particular view version was made current. Okay, let's take a look at a demo. Oh, by the way, so you can run. So it's a Jupyter notebook. I'm not going to run a live demo. It's we care less about the full demo, but more about what actually happens at the metadata layer. And so I created the Jupyter notebook a while ago, so you can just grab it. Feel free to play with it and try it out. So we will only look at a subset of this demo because, like I said, we really care about what happens at the metadata level. So think about the following sequence of operations. Assuming we create a table, we insert some data into it, we create a view, and we then update the view by replacing it. So what we're doing here is, we're creating a view. We're creating a table called NYC taxis. There are about like 20 different columns. Like I said, details don't matter that much here about how the table itself is created, is looking. We go ahead and use the Spark data frames API to write a bunch of data, and we just take a look at the data to see there's some data, right? And there's a pickup time, drop-off time, passenger count, trip distance, and then some other stuff. So what we want to do right now is create a view where we want to have a look at the longest distances traveled. So we're creating a view called long distances, and we give that view a custom schema. So there will be the vendor ID, pickup date, drop-off date, distance, and total with some column comments. And the underlying SQL will essentially, query those columns from the taxis table, and we order by trip distance. So we just take a look at that view, we get that data, and now what we want to see is what happens at the storage layer. So this demo is running, by the way, using Spark, REST catalog, and MinIO. And if we take a look at what is inside the bucket, there will be, this is my warehouse. Long distances is the view name. There's a metadata folder, and there will be a metadata JSON file. Looking at the content of that file is there's a view UUID, just a unique identifier to identify the view. There's a format version simply because, pointing to version number 1, simply because that's the first version of the view spec. There's a base location where all of the view metadata is stored. There are some properties indicating, this is, there's some properties that Spark added. This was created by Spark 351. The view has a list of schemas. There's currently just one entry, schema ID 0, where, in the schema, we see our vendor ID, the pickup, essentially all of those fields that we find with the column comments. And we see the current version ID is pointing to version ID 1. So looking at the list of versions, there's a version ID 1 created at that timestamp. Sorry, my headset is shutting off. So I hope you guys can hear me. We stopped at the current version ID. Like I said, the current version ID is pointing to that version where the view version was created at that time. There's a that view version points to the schema ID 0, which is this one, and we see the actual what is the representation of that view, and that is exactly that underlying SQL that we defined earlier, and the dialect Spark, simply because this was created by Spark. If you remember the architectural overview of Iceberg, with the catalog and the metadata and data layers, that's essentially what we would get. So there's the catalog, and that catalog points to the latest metadata file that we just saw. So we weren't really happy with the underlying query. The view didn't provide the right results. So what we want to do is we want to update the view. So we replace the view essentially. We slightly modified the ordering of the columns. We put distance, total, and min to the top. And we also update our condition here. We say, where trip distance is greater than 35 and ordered by total amount and trip distance. We created the view. The details don't matter that much here. But what we want to see is what is happening at the storage layer. Looking at our bucket, we will see a new metadata file. So this was the previous one, prefix with the 0, and there's a new one with the 1. And if we now look at that content, going from top to bottom, there's view, UID, format, location, properties, and stuff. Nothing changed here. Where things changed is the schema. So there's a new schema entry with schema ID 1. The previous schema ID still exists. I just collapsed it so that we can see everything on one page. And we see our new schema for that view. We have essentially reordered columns. That's why we have a new schema for that view. The current version ID changed to number 2. Looking at the list of versions, there's still there's a version ID 1, which was the previous one, and the version ID 2. And like I said, the current version is set to point to this one. And if we look at the details, that view version points to schema ID 1, which is this one. It has, tracks some additional details, and there are the representations. So that's exactly our new query that the view is executed when you query that view. And looking at the history, there's a new entry. It was changed from version ID 1 to version ID 2. And so looking at the architectural picture of like what happens underneath in the catalog. So it's a catalog that is supporting views. So the catalog will make an atomic swap. And once that was successful, it will point to that new metadata file. And so whenever an engine comes in and asks, what is the current version of the view, it will go to the catalog, and the catalog will say, oh, I'm pointing to this metadata file, and this is the latest version for that particular view. Okay, looking a bit into what is going on right now in the community, and also what is future work that is ahead of us. There are a bunch of things that are being tracked for like adding view support for like metadata, adding metadata tables for views, similar to how they exist for tables, and some other things. So those are being tracked on GitHub. Also, part of integrating views into Spark meant that we had to first integrate all of the Spark data source v2 support for views into the Iceberg code base. because it would have been very difficult to first release this, get this into Spark, release this in Spark, and then get it into Iceberg. So this would just take a very long time. And so what we want to do is essentially contribute what we did in Iceberg back to Spark, so that Spark's data source v2 get full view support. That is what I also mentioned earlier. So right now we essentially represent views using plain SQL, and whenever that plain SQL, whenever that engine executes, it just takes the SQL as is and executes it, and parses and executes it. But long term, what we really want to do is we want to represent views in a more engine agnostic way, using some form of an intermediate representation. There are projects out that can help. One that comes to mind is Substrate. What the community currently is also working on is support for materialized views. So there are discussions going on dev mailing list. There are some PRs out to write out what that means in terms of the spec and the implementation. And obviously, we also want to add view support to other Iceberg catalogs and engines. So there's a bunch of work going on, and I'm very excited about what is happening in the community around this. So, and if you want to help out, there is always contributions are always very welcome. Feel free to ask questions on the dev mailing list on Slack, and or GitHub issues and stuff, and yeah. So I hope that gave you an overview of why Iceberg views exist in the first place, and how they, what essentially happens when you create a view, update a view, and what happens at the storage layer, and how, what the details of how we represent views look like. So thank you.
All right. We have a lot of great questions. And get right into some of the clarifications that I think we were wanting to get into from the earlier part of the chat. So I want to dive right into this one because this has the highest upvotes and is like actually a really good way. But how does having a dialect field not undermine the goal of a common view standard that works seamlessly across engines?
I mean, yeah, when we were working on views, there were a lot of discussions, how do we make this in an efficient manner? How do we represent views in an intermediate format? But it's very difficult to do that, right? So there are a lot of things that need to be done before you even get to the point where you can represent views in an intermediate representation. So we decided to, as a very first iteration, define the view spec and go with a plain SQL approach. That means one engine goes and says, like, my view, I'm creating that view, the SQL is that and that. And if another engine looks at that view representation, it can decide and essentially make a best effort. And I mean, that's what we do in Spark. We essentially do a best effort and say, okay, there's a SQL representation. Spark will go ahead and try and parse it. And if that works, execute it. And there is still risk that it might produce different results, but it's still far better than not have any view support at all. Simply because, the community has been asking for views for, I don't know, like many years already, and it took quite some time to get views to the point where we have it. And like I said, the decision was to, let's go with what works right now, and we can iterate on that and work on an intermediate representation for views to make this even more portable.
I also like to take the view, if I add just a little bit to that, is like Iceberg tends to not want to take opinionated stances right away. It likes to slowly work its way in, right? So I don't know if you want to say any words more on that, but yeah, it's having a dialect field initially might indicate that we're going to do SQL or have Pythonic ways to do it. You can actually say the dialect is going to be some sort of internal representation, and you have that flexibility. And then how you manage that in the future will be something that we can address in future versions. Is there an engine that you can use, right? And this is stuff that's not even discussed yet at this point, because again, we're just trying to get the bare bones SQL to SQL and best effort thing right now. But what this keeps, it keeps the unopinionated version of the view spec, so that we have a lot of different avenues to take, and it doesn't trap us into a particular way of doing that.
I would even say, going with the dialect and the approach that Iceberg is taking right now would, get you to 95%. Like there's, like I said, there's still something left. Like there's still some edge cases where, the SQL might not be portable and not being representable in a certain engine. Yes, that is possible. But 95%, you will solve 95% of your problems, I'm sure.
Yeah.
And we're going to work as a community towards, making that even better and having some form of intermediate representation.
Yeah. As an option, yeah, and that's definitely something you can grow into. Are Iceberg views supported in Athena today?
I cannot speak for Athena. I mean, I don't think. I haven't seen anything in the Iceberg repo for. Yeah, I cannot speak for Athena. I know they had
don't believe
the
they
Athena
have.
guys have been working on something. I just cannot make any definitive statements about that.
Yeah, I've kept up with that just a little bit, and they're mostly waiting for an upstream change to Trino, and then kind of incorporating that. I don't know if there's any plans to release something sooner, but I think because Trino's so close, it's very likely that's kind of going to predate any development going on for Athena. Is time travel supported on Vue to visit older versions of Vue definitions with latest data? I'm sure this was answered after this was done, but just to make it clear.
It's currently not supported.
Yeah. So can views somehow be used for some sort of access control? Imagine I want to make some columns visible for certain clients due to GDPR, and I want only some portion of that data to be like queryable through this view.
I mean, yes, that's one of the core ideas behind views. Like you give people access to a subset of your data, and the security part is part of the engine. I know Trino has a way of like run this view as an invoker or as whoever defined the view, so you can give people access to only non-sensible data.
Okay. There was a previous session on Coral Iceberg, and it manages incremental views. Any thoughts on adding Coral as the common representation of SQL instead of separate SQL dialects?
I mean, that essentially goes to, how do we long-term defining an intermediate representation. I mentioned substrate. I mean, Coral is also an option. This is just something where we need to do research on and discuss and define what we would like to use. But it's on the table, right?
And if you look at the way that we approached catalogs, right, you might see a similar way that we might approach these different ways of doing intermediate representations, right? There could be, you could have SQL glot, or you could have Coral, you could have all these other, or the, what's the other one? Substrate, right? Have all of these things be something that the view keeps track of in terms of how we do intermediation, and then that chooses the engine or something like that. But again, I think Iceberg, when it approaches specs, it's trying to do the least opinionated thing possible. And so Coral definitely will be a part of that. And then it's just kind of seeing what the community actually adopts and and prefers over time. Cool. I noticed that the schema is part of the view definition. What's happening if the underlying table schema changes? Great question.
That's a good question. Yeah. Essentially, what will happen is when you query the view, what will happen is whatever the underlying SQL that is targeting the table. If that doesn't align anymore with the table, the query will just fail. That's it.
Yep.
It's just similar to if we would just take the underlying SQL as is and would just run it in Spark or Trino or whatever engine. That's how it is. There's no referential integrity that would guarantee you that the view schema and the table schema is always in sync. It's just when the view is executed, whatever the underlying SQL is being taken, parsed, and executed. And if that doesn't align with the table, that will fail.
That said, though, I mean, with the way that Iceberg is set up, right, you have full capabilities to, do those checks as a tool that you could write,
Exactly. It's just not something that is being currently done.
Yeah.
Let's put it that way.
Will view definitions always be resolved at the time of the query? Assume we have, this could be. Yeah. Okay. This was a similar kind of question.
Yes. I mean, the answer is yes. The view definition will be resolved at the time when it is being queried, and the underlying SQL is taken as is. And if columns or whatever doesn't align, your parser of the engine will just say, either parsing failed, or I cannot find those and those columns, or the types don't match up or something.
So we answered this one already, but I do think it is good to hear it in different questions, like similar questions being asked in different ways. When creating a view, the idea is to produce more dialects, Spark and Trino. What is the mechanism responsible for transpiling the DDL from one dialect to another?
I mean, yes, technically the API allows you to carry more dialects. Right now, it is just from an engine perspective. An engine goes in and writes its own dialect with the latest version. But the APIs are available to say, I'm carrying I'm carrying multiple representations for Spark and Trino. And when essentially when you have that, like I said, it's there. It's supported in the APIs. Every engine can then go in and say there's a representation for my dialect, so I'm going to use that. And there's a different representation for, Spark or Trino. I'm going to use that. That is what we're currently doing. And if what we're doing in Spark right now is if there is, we're doing a best effort, like I mentioned before. If there's no dialect for Spark available, then I'm going to do a best effort and still try to parse the view. But the top priority is always, use the dialect for my engine.
Will we be adding view support in Hadoop catalog?
We're discouraging people from using Hadoop catalog. So the answer is probably no. But I mean, if you are interested and you think it's something very valuable, work with us, work with the community. But we discourage people from using Hadoop catalog.
Yeah. Are there any maintenance procedures required for views like the expiring view versions? And a similar question actually asked, what should the process be if we need to refresh underlying views, if columns are added and that kind of thing?
There's really nothing you have to do. I mean, views are essentially just the metadata files. There's no, I think you said what, refreshness?
Yeah, how refreshing let me see. There's that original question. So there I combined two questions actually. So there's maintenance procedures for
view versions.
Yeah.
I mean, no, there's really not much maintenance you need to do. Other than maybe, eventually clean up the metadata files, but that's about it. It's much simpler than Iceberg tables.
For example, one thing you could possibly do in the same way that you would, look at a current view, like your current version, and verify that those things still exist. You might be verifying that previous view versions also have a valid state. Again, that could get expensive depending on how often you do that and how many views you have and this kind of thing. But you can check all these views and you have all of the data in the catalog to verify that these columns on these underlying tables still exist. It's just a very arduous, potential process, and it depends on, do you just, are you eager to try to avoid those things versus just finding them out and then, updating it at that point? Depends on your use case, I guess.
So I think we can do one more question. I saw multiple questions around the .gzip format in the metadata file.
Yes.
Yeah, it's essentially we're just compressing the metadata file. It's gzip compression. That's what we do by default, and that's it.
Okay. All right. Well, we are going to be ending. I think we do have time for one more. I think people are asking about both the Hive catalog and as well as the concept of views for Nessie.
Nessie already supports Iceberg views. That went out with the Iceberg 1.5 release. View support for Hive catalog is currently under review. So there's a PR open. It just didn't make it into the 1.5 release. So I'm assuming it will be shipped with the next one.
Okay. I think we still have a couple more minutes. What is the motivation for having older versions of the metadata, of view metadata? And how do you get access to the older versions?
You mean the actual JSON files?
Yeah, it sounds like the older versions of the view itself. What's the motivation or thought around those use cases?
I mean, that's essentially what Iceberg does for tables. When you create a new metadata file, and if there's a conflict, it isn't being made current, so you still have the other one, the existing one, right? And you have multiple metadata files. I mean, technically, you could just take the latest, and the latest always represents the full state of the view. So technically, you could get rid of the others, but this is how Iceberg creates the metadata files when updates happen.
And I think the very last one, let's see. So does this mean every time a view is executed, the engine reads data from the Iceberg tables, or is that, okay, yeah, no, never mind.
Yes.
It does every time. Okay, cool. I think we've covered all the questions then. Edward, thanks for basically, giving us this in-depth review of views. Is there anything else you want people to know about how to get involved, or how to get, if they're interested in views, what to know from here?
Well, I mean, like I mentioned before, get involved in the community, ask questions on Slack and Dev mailing list. The community is very welcoming. Play around with views. If you find some bugs, that is always great. Like the more people play with this and try it out, the more everyone benefits. And this is what we ultimately want. We want more people to be engaged in the community.
Yeah. Trino views are definitely coming up for those that were asking about that, and very close to getting merged, just requiring some valid or review on the Trino side. So expect those to come in shortly, and then be able to really play around, not just with a single query engine, but multiple query engines and across multiple catalogs. So thanks again, Edward.
Thank you, guys.
We'll see you all in the next event.